In this question, we're asked to calculate the gradients of these two lines. So let's look at the graph on the left. This graph has 2 points plotted on it, -3, -4, and the point 1, 2. And using those 2 points, we're going to calculate the gradient. And we're going to calculate the gradient using a formula which says that the gradient is equal to the rise divided by the run. So let me show you what those two things are. I'm going to draw a triangle from this left-hand point, joining on to the right-hand point like that, with a right angle there. And the run is this distance along the bottom, and the rise is this. So the words come from a staircase. You can think of the run as being the distance you go along a step, and the rise the distance you go up. Okay, so the run is equal to the increase in the x-coordinate when you move from the left-hand point to the right-hand point. And that's this distance, and you can see from the x-axis that that distance is 4. So the run is the increase in x and that's 4. Now let's talk about the rise. Well, that's the increase in y. As you go from the left-hand point, this one, to the right-hand point. So how much does the value of y increase? Well, you can see again by looking at the axis that it's 1, 2, 3, 4, 5, 6. Is 6. Now, it may be that the numbers are not quite so straightforward as they are in this question, and so there is another way of working out the run. The run is equal to the difference in the x-coordinate of the right-hand point. The run is equal to the x-coordinate of the right-hand point minus the x-coordinate of the left-hand point. So the run in this case is the x-coordinate of the right point, 1, minus the x-coordinate of the left point, which is -3, and that again gives you the answer 4. And the rise is the y-coordinate of the right-hand point minus the y-coordinate of the left-hand point, and that's 2 minus -4, and that's equal to 6. So either way, we find that the run is equal to 4 and the rise is equal to 6. Now the gradient, as I said, is equal to the rise divided by the run. Well, that's 6 divided by 4. 6 over 4 is equal to 3 over 2, and that's equal to 1.5. Now look at the second graph. Again, we're going to calculate the gradient using the coordinates of these 2 points. So let's draw the triangle again. So this is the run, and this is the rise. And the run is the increase in x. And that's as you move from the left-hand point to the right-hand point. And you can see that the increase in x when you move from the left-hand point to the right-hand point, you go from 1 to 3, so the increase in x is 2. Now what about the rise? Well, this is the increase in y. But here the y value in at the left-hand point is 4, and at the right-hand point it's 1.5. So actually the y value decreases rather than increases. That means that the increase is negative. And it goes from 4 to 1.5, so the increase in y is minus 2.5. It's actually a decrease. Well, you could have worked that out the other way, so let's do that. The run. You can work out the run by taking the x-coordinate here and subtracting the x-coordinate there. So it's 3 minus 1 equals 2. And the rise, similarly, you take the y-coordinate at the right-hand point and subtract the y-coordinate at the left-hand point. So that's 1.5 minus 4, and once again you get minus 2.5. So now we can calculate the gradient. The gradient equals rise over run, and we plug in those numbers. Minus 2.5 divided by 2, that's minus 1.25. Now if you look at those two examples, in the first case the gradient was positive, and that corresponds to the graph rising from left to right, increasing from left to right. And in the example on the right, the gradient is negative, and that corresponds to the graph decreasing from left to right.